Hi guys. Hey, how you doing? It's Miss Murphy again. Yay! Time for some chemistry, Unit 0. I'm gonna quickly discuss this, like how to take correct measurements. Like there's a way, right? Well, there is. So it's real simple. I'm gonna go through it pretty quickly. The gist of it is that you should always guesstimate the last digit. Excuse me. We'll be doing, imagine using a ruler. I said these things in class, using a ruler, a graduated cylinder, a triple beam balance, a thermometer. You should always guesstimate the last digit. And so let me show you what I'm talking about. Okay, I'm gonna go to my awesome little whiteboard here. And now you're with me. So we're looking about how to make, let's show you how to make correct measurements. Miss Murphy needs to get some more markers. How to make correct measurements. Let's put this marker aside. I'm gonna throw it, and it went right into the trash. Perfect. Okay, so basically you need to always guesstimate the last digit. And how you do this depends on the device that you're doing, right? Basically, you want to have as many sig figs as possible. Or let's see, I could say that better by you want to be as precise as possible. Okay? That's what you want to do. You want to be as precise as possible. And that's what we get when we guesstimate or estimate the last digit. We want to keep as many significant figures in our measurement as we can. Okay, so the device that we use limits our precision, not our using of it. Okay, this won't take long because there's not much you can do here. Let's say that we have a graduated cylinder. All right, so it's gonna be a long column. And I'm actually gonna draw a couple of these. All right, and let's do this one here. And hopefully this works out well and I don't make too many silly mistakes. Oh, let's get you there. Look at my graduated cylinders. Okay, this one's gonna go 1, right? 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, 2.0. Do not write 2.0 milliliters. I'm not worried. I'll make it skinny so that nobody says anything. Right? I'm not worried about my drawings, even though I'm erasing them. Okay? So this here. So what I see, guys, is that each individual increment is a 0.1, right? 0.1, 1.2, 1.3, etc. Okay, so this would be 1.0. Now, if my liquid, whatever was in here, was to this point, right? Took up this much space. This would be measuring volume. I would see that this volume, first of all, it's going to take the shape of a meniscus, okay? And yes, Miss Murphy just said the word meniscus. This shape is called a meniscus. All right? And it usually kind of goes like this, right? And you want to always read the bottom of the meniscus, not the tops, but you always want to record the volume. So you might want to hold this up so that it's at eye level with you. Okay? So that tells me that my measurement falls right about here. Okay? It falls right about there. So I know that my measurement is greater than 1.4 and I know that it is less than 1.5. Okay, so I need to guesstimate the last digit. I know it's 1.4 something. Okay, so let's see what that something is. It looks like maybe it's about a point. It's almost a 1.5. Maybe it's greater than 1.45. It's not in the middle. So I'm going to give it like a 4.7 or a 4.8. This is your graduated cylinder. These would be milliliters, okay? We would know that. The point is, I did not say 1.4. I did not say 1.5. I guesstimated the last digit. I now have a measured value that has 3 sig figs. Okay? Okay. That's it. I needed to guesstimate the last value. I'm going to do a couple more things here. I'm actually going to erase. Well, let's come over here. Make him a little skinnier. Let's look at another example. It won't take too many examples to get this point across. Let's go 1.0. Oops, running out of ink again, aren't we? 1.1, 1.2, 1.3, 1.4, 1.5, 1.6, 1.7, 1.8, 1.9, 2.0, and we'll just stop there for the purposes, okay? This is in milliliters. Let's say this time that our volume was right here. So that the bottom of our meniscus was perfectly, what I'm trying to do, guys, is get the bottom of my meniscus perfectly on this line, okay? So this is where I should read. Now I see it's perfectly on the 1.1 milliliter line. Oops, let me go down, right? It's perfectly on that line. Well, it is not sufficient to say it's 1.1 milliliters. I know, I'm going to say it's 1.10, right? This is my guesstimated value. If I just say 1.1, I've recorded a measurement with only 2 significant figures. By guesstimating the last value, I've recorded a measurement with 3 significant figures. Always guesstimate the last value. Let's do this again over here with my other graduated cylinder. Let's this time say that this is 1.0 milliliters. This will be 1.5 milliliters. This will be 2.0 milliliters. This will be 2.5 milliliters. This will be 3.0 milliliters, 3.5, 4.0 milliliters. So what you see is we've lost some of the accuracy, right? We don't have as many tick marks. Here we have one every 0.1, here we have one every 0.5. What's going to change the way I have to use this device, all right? This is going to give me more precision. This is going to give me less precision because the tick marks aren't as precise, right? So let's get a measuring here. Let's say that we're about here. Okay, give it a curve because it's going to be a meniscus. And we see that this comes right about here and right about here, okay? So now we know that it's greater than 2.5 and it's less than 3.0. I can't go to the hundredths place as I did here because my accuracy ends at the ones place, right? I know it's between 2.5 and 3.0. That's all I know is that it's greater than 2 and it's less than 3. It's greater than 2.5, it's less than 3.0. Okay? So this, I would have to round, I would have to say, let's see, if this is 2.5 and this is 3.0, maybe we're at like 2.7, or maybe we're at like 2.8. I couldn't go any further. I don't have enough information to go any further. Okay? So it can be a little bit tricky, but it is a very important skill. Let us do one more. Those are my students. Remind 101 all day long, guys. We'll look at one more. Right? 1.0, 2.0, 3.0, 4.0. All right? Please stop all day long. Okay? Let's look at this one. Let's put our number right here. Or that would be our liquid height. Remember to always read the bottom at the meniscus right there. Well, all I know is it's between 2 and 3. It looks like it's pretty much in the center. So I'm going to guess 2.5 milliliters. It would be wrong to guess 2. It would be wrong to guess 3. This is my guesstimated, estimated value. All right. Okay. Like I said, this is pretty short and sweet. Let me go ahead and go back to this one again, because this is the mistake that I see students do all the time. They get out their graduated cylinder. The directions say, get 3 milliliters of hydrochloric acid. They get it. They get their 3 milliliters, right? They get their 3 milliliters. They come over to their data chart and it says volume. Volume of whatever. Maybe it's hydrochloric acid, right? And they go 3 milliliters. And Ms. Murphy goes, come on, guys. This only has one significant figure. All of our calculations are now limited to one significant figure. Aren't we supposed to guesstimate that last digit? 3 point what? It looks like it's right on the line, guys. It's not always right on the line, but this time it is. So you need to write 3.0 or 3.1. Let's use as many significant figures as this device will allow us to use. If you've watched the calculations in Sig Figs, you see how this is going to greatly limit our answers. Everything would have one significant figure if we had to use that value. We have used as much precision in our answer here that our device would allow. You've got to guesstimate the last significant figure. Don't let your measurement limit the Sig Figs and accuracy. Let the device, the tool, the piece of equipment, the measuring tool limit your significant figures. All right? Okay, that's the most important thing there. And if I come back here, you'll see me again. That's what I need you to do. Okay? Till then, I'll see you later. That was really short.